Okay, guys, as promised, to show you the graphs I'd like you to make, and which we started on, and some the analysis things I'd like you to do. So first of all, remember, it's quite simple to just make the graph. Just select the two, go to Insert menu, and I decided for especially the 50 and 100 megahertz to do it actually scatter plot with the straight lines and markers. And so there it is. Notice that each of these I've changed the range from 2 to 8 seconds, and then you can see then nicely several of the shapes. And then what I did too is let's see the series. So like as we did before, you can cut down the size of the line. There we go. That looks nice. Then I did add a marker, and I made it quite small. And I made it a slightly different color. So it's that and this is the outline of it. It's still blue in the middle. Well, that's okay. That works. And just so that you can see that a marker actually is there. Let's see. So data series, and the point of it is to let the reader see that it's there's samplings going on. After you get above this, you can't really see them as separate dots anyway, and we're not going to do an averaging on these two. But the point is, it's just not really. I mean, maybe someone could make a case for this guy that you can see the different parts, but I don't know. If you know what you're looking for, yeah, that they're there, but I don't think that one can reliably say that you have these the different parts of the trace that you're looking for. The normal sinus rhythm. Okay, and same thing for here. You can sort of see it, but it's not that great. So now we look at the 250 megahertz, and at the moment I have the trend line. Now, how can we make it visible? Well, I guess we could say no line for a moment. There we go. So now we can certainly see the different artifacts, the fiducials, they call them, the landmarks. But let's see. Oh, I have to. What did I just do? Solid line. Oh, border. No, we don't want to. Border. Trend line. So no line. And even now, okay, it's kind of there. But the idea is now we're starting. Yeah, we have more points, so we can sample the waveform. But the problem is that we're letting in noise. So then we inserted the trend line, and we go to the trend line options, and we can sort of see. Now it shifts to the right, and that has to do with, and you'll see in a minute, you lose the points. Everybody gets. It's kind of hard to explain it really succinctly. I'll just show it to you. So you can. And then you start to see. So you'd say, look, we did a moving average of 11 points, 12 points. The shift to the right isn't so bad, but we notice that the shape of the various parts of the EKG have changed, And so this is not acceptable. So, and we notice we have a serious degradation of the amplitudes, but most importantly, the shape has changed. We see with the moving average of 4 that it's looking pretty good, right? So then we can go here and let's say, so now we can actually get rid of the line of the data, and that looks pretty good. Could be better, I suppose. And that's why one might decide that one wants to choose the 500 megahertz. And then with the 500 megahertz, oh my gosh, it looks horrible. But when we do the trend line, we can average quite a few. And we don't screw it up because there's just so many points that it still looks pretty good. So it looks like 6 is the way to go. And then if we were to look at the series here, we get rid of the line, and you know, that's just nice. Okay. So for an analysis, you want to show something, maybe make a couple different plots like this. Say, look, here is the raw data, here is the fit with the trend line with so many samples. Because the idea is you're trying to show that you're improving things. And so we notice now we do this, and well, this actually still looks pretty good. Let's see. Yeah, it's amazing. You really can. So we don't really see a lot of difference between them. So there's really, with the 500 hertz, you just can do no wrong when it comes to averaging until you get to really high. Because what happens is now, if you were to see, like, this is about 1 second wide, it's 500 points. So averaging them, let's see, how high can this go? Quite high, huh? So I'm thinking, yeah, now we're seeing some serious degradation of the shapes. Okay. I wasn't paying attention. Yeah. So I was going to say 1/10, but we need, with 50 points, 500, yeah, 500. Now we're doing 50, so that's 1/10, less than a tenth, 1/20th, 1/25th. Yeah, so 20 out of, like, say if it's 1 second wide, is 500, so 2 over 50 is 1 over 25, right? So this is probably the limit, a moving average of 20. So there you go. So moving average should be no more than 20 divided, if you have 500 hertz, we're looking at 20. So that's 2 over 50, so that's 1/25th, right? So if we add 250 hertz, the most we should do is 10 for averaging. Interesting, huh? Okay, so somehow, no, not somehow. So we're doing a trend line. We're using it to show the moving average, and how with the high sample rate, yes, we get more noise, but we can overcome that with the averaging. And this is where computers really help once again. So even if I take this to say 10, and there you go, even 10 looks really nice. 10 looks great. Okay, great. So you need to really understand what a moving average is. So let's we'll do this as an exercise. So if we say 10, so we have to start here. So now let's take, we're going to take an average of the time. So this equals average of these guys. So that's actually, let's see, that's 9. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's 10. And same thing here, equals average of same number. And now I take this and drag it down. And this takes quite a long time because it's 500 hertz. But we only have to take it to 8 seconds. Let me close enough for government work. There it is. So this is T AVG, and this is voltage AVG, and then this is the so now we can, well, let's just for the time being, in fact, how are we going to do this? Let's take this cut. It's probably a pain in the ass to put it onto the same graph. So we'll just make a separate graph. So moving average just means that as you move along, it's just averaging the 10 values before where you're at. Come on. Blah, blah, blah. Oh, there it is. Okay. So then we insert scatter plot like so. And we want to make it 2 and 8 again. Eight. And then we bring it up to the top. Oh, this is going to be a pain in the butt, huh? I know what to do. I'm just going to go cut. And then I'm going to paste it here. Paste. And then I can set it up to compare. And there it is. See, it looks exactly like the trend line. And that's just an exercise to demonstrate that you know what it is. Very simple. Okay, then the next step was you're supposed to measure parts of it. And so, excuse me. So let's see, we're not even going to bother with the 1 kilohertz data. Good enough what we have here. But I want to just save this so I have it. Yep. Oh, and I just call it O1A. So then I can reopen the last one and still have this data, so I'm going to get rid of this. Delete. Okay, so we need to decide what we want. And so let's see. Now I'm going to tell you not to bother filling in those whole tables. Like I said in class, too much work. I'm also already asked you guys to do a lot of work on this one. So let's just see what we're supposed to measure exactly. Using table 2, the beginning of the P wave. In fact, what we need is let's do a snapshot of that. Yep. So we have that to refer to. And where are you? Here we go. And we need a snapshot of the actual waveform. So I can see where I've got to improve this even. All right. No, not there. And paste. So hopefully that goes on the front. Yep. And so it says the beginning of the P wave. Oh, so that's the PR interval. We need the PR interval. So remember I was saying in class, how many vertical lines do we need? So it looks like we need the PR interval. So we need 1, 2, because then it says the beginning of the Q. Shown, let's do this. Or do you get the time? Okay. Measure the time from the beginning to the beginning of the T wave. And the T wave is here, the beginning of the T wave. And okay. So that's, well, we only need 3. Well, you know, I'd like to know what the QRS is. So I want 4 vertical lines. Okay. Now, let's make some room here just so we can see what we're doing. All right. T1. So let's see. Turn off the tablet. So actually this is beginning of the P wave. And didn't that look good, huh? I'm gonna pause for a minute. All right, I'm back. You didn't notice any difference. So beginning of the P wave, beginning of QRS, end of QRS, beginning of T. And then I have a column for y-axis points. And then I have the P to QRS, the QRS interval itself, and the QRS to T as stated here. So I suppose this is the this is what the ST, and then this is the PR. Okay, so we know exactly what we're talking about. So I'm going to end it up on this graph here. One thing I do, I'm going to copy and I'm going to paste. So now I've got this one, and I am going to get rid of I just want to keep the trend line. So I'm going to get rid of there we go. And then we could change this here. And let's call this 1.5. Nice, huh? Cool. Okay, so we see this goes from -1 to 1.5. So that's our y-axis minus 0.1, excuse me, and 1.5. And I noticed that this first one is at about 3 seconds. So I'm going to put a 3 there. And oh yeah, I can get an estimate. In fact, I have another idea. Right. So wait a sec. I am going to take this and I am going to copy, and then I'm going to insert. Yeah, okay, good. You'll see why I did that in a moment. Okay, so these are these are numbers I'm going to put in or calculate. There we go. So let's see, about 3. This is about, oh, it doesn't say that, yeah, because it's a trend line. Okay, so we'll just call that 3.2. We can fix this, you'll see. 3.2. The end, let's say it's at 3.4. We just have to estimate. And then this is, say, 3.5. And then I'm going to, give me a minute. Right, so then I'm going to insert, I'm going to add something else here called, I'm going to call this offset, and you'll see why in a minute. And it's first going to be 0. Okay, so begin of the P wave is going to equal this plus the offset, and then equals this plus the offset again. If I were, well, here, watch, I'll show you how to do it better. Y2, we do the dollar signs with the F4. And then we can just drag it across. And then if I add the offset, they all change. So that's going to change the position of the vertical lines that we're going to put in there. And you'll see why we're going to do that in a moment. So P to QRS is going to equal this minus the P, and oh, excuse me, that's not what I want, because I need it to be, I need the offsets in there. So that's going to be equal to, yep, the P2 here minus O2. Yep. And then this, can I just drag that across? Yes. Because, let's see, this is, yep, that gets us to QRS. And that gets us the QRS to T. Nice. Okay. So then, this now, it's kind of dumb, but we just say equals to what's just above it. And we drag that across. Sweet. Now we add select data. And it's a little tedious because it's going to be 4 different lines. Add. So begin. And then the X values are here. And the Y values are here. And where is it? I don't see it. Why is it not on this graph? Well, let's say okay. And pause time. So I just realized a mistake I made. We don't want to use, remember I copied and pasted the 500 hertz, but actually don't want to use that. I want to use this new one I wrote, and this is, let's make it more formal, voltage, millivolts, 500 hertz, 10 AVG. There we go. And we want a different title than that, but that's the name of the data series. And so what do we say? 2 to 8. There it is. We want to add this, and I know why it didn't show up a minute ago. Select data. So add once again. Gotta, oh yeah, once I do this, I can scroll up, begin P wave, and then the X values are here, and the Y values are here. So yeah, there it is. Nice, huh? Okay, so I'm going to pause now. I'm going to add the other ones in. So I just realized that I should show this because little subtlety. You probably got it, but let's just make sure. Now I'll add the 4th one, and that is the beginning of the T complex. And then the X values are here. And so each time I'm choosing a different X values, but the Y values are the same. And even though it's only 2 points, I get lines because this I have told it to be a line. So this here is not a good color. We don't want blue. What have we not used yet? Sort of dark greenish, huh? Okay, so now we can tweak this a little bit. And so it looks like 2.8. Ooh, no way. 2.95. There we go. 2.96. And it's getting there, huh? 2.97. Nice, I got that one. So I'm going to pause. So now I've made it to messing with the beginning of the T. So let's see, it was 3.4. Let's make it 3.3. Oh, no, maybe it was 3.5. Let's see, 3.4. Ah, there it is. 3.45. And so on. So you see how you mess with that. And now you get the intervals they want. And I made it easy. Now what you can do is you can just offset it, meaning like I want to move to the next. I type in the 1, and I see where, okay, let's try 0.8. And it needs to be a little bit better. In fact, I even have something clever to do to make it, to do the offset even better. 0.9. And so forth. So now you can go and just double check each time to see if the intervals are basically the same. And pretty nifty, huh? But there it is. So that's how you can measure the numbers they want. So for us, we just want to double it. The important thing is that we understand what the averaging is. And excuse me, and just to do a couple measurements of the of these numbers they want. So this, of course, can be jazzed up. We don't really need all those significant figures, for example. So we can get rid of, it says link to source, so we don't want to do that. So, oh, sorry, this, we can do it here. So 0. So, well, maybe I like to have 1 decimal place. It looks a little nicer. There you go. And same thing here. Oh gosh, maybe just 1 decimal place. And then you can add labels. You go up here. And there you go. Neato Kino. I just realized I forgot something. Well, I mean, you should know it by now, but it's always a great, among other things, a title for the graph, titles for the axes, what the legend. It really helps. It helps when you're actually making the graph. But and then you can, I always put it in at the top. Then you can format it. I just noticed that I liked having them all stack up like this. I can make a background fill so that it hides the grid lines behind it. And you can change the size of the font. And yeah, nice, huh? There's even a way to add to the legend these numbers here, but let's not go too crazy. Great. So at the end of the day, you're going to have the 4 basic plots. You're going to show this with the trend line with the moving average of 10. And then you're going to create a moving average. Make a plot of that. Make the vertical bars. And measure these intervals for a couple of these. Just to see, to demonstrate that you can do it. And you can make a comment as to whether or not it's normal, but I'm not asking you to do the table 2 and 3 in the manual. So that's out. Very good.